It's with models in class systems fail, irrespective of their intelligence, irrespective of how accurate your models are. It doesn't matter if it's surrounded by a system that doesn't perform well, it's typically fail. It's an overall failure in terms of user satisfaction. And there are other places where your models might not be the most accurate, but when surrounded by the right systems, it actually tend to be right better. And a very good example is, and I'm talking about intelligence in particular, not uh, I'm talking about those building systems that have genuine intelligence. And a very good one is Google. If you've ever used Google for a very long time, maybe before the advent of LLMs, you might realize that the entire time could actually just ask the chat to the search engine many a times and to definitely try to figure out what you're talking about. And this was before the advent of ChatGPT and LLMs. Like, for them, creates some sort of intelligence, right? And after that, YouTube as well, you have Netflix, you have Amazon. Amazon search engine as arguably one of the best search engines. I'm referring to like the Amazon e-commerce sites. You can trust there and it's much better. It's just because it's not the most intelligent model, but it's just surrounded by a system that is very resilient, very fast tested. And that's the end at the end of the day, right? Okay, so yeah, and that's pretty much it. And the second element diffusion is once the model is built, we're done. Was I'm able to train a model and then have to get some data and I see this with the right results. Okay, I think I've got that part. So someone like me, when I do the major part of the project, I can pretty much go to the deadlines and I see I'm like done still things to do because the compass is done. Right? What really matters is building the system around the model is just as important as the operation of the model itself. And at no point in time should you as an engineer decide to trade off systems for accuracy because accuracy is powered by systems. When I refer to systems, I'm not referring to systems, I'm referring to thinking of things holistic. I will get to it when I refer to concurrent thinking systems. Right. Okay, so very common one, common flow, for example, is you write your notebook or Colab, everything works, the model is deployed, and then for some reason, let's say we're doing it for a company, and then you need to capture it or track things on the project. And then you realize that okay, the inputs that are coming in are different. These are extremely complex. And something is if you don't have the right system in place, we realize that there's basic background things. And you start to wonder, I just said it's not go. I have several ways of doing it. All my several edge cases works. But why is this not giving me the right results? No. And many times if I notice this first, other times if I notice it for it, there's even if there's a problem, if you notice this first, you already have an edge because I'm better off if my bank tells me there's a problem, don't open the app yet than when I try something out and then I realize there's a problem. So, it's all there's a problem on this, but how the message is passed matters, right? Okay, so let's talk about system thinking for ML. Now, when I speak system thinking, I'm talking about holistic thinking. When I say holistic, I mean I'm trying to you making sure several components of the very grand picture are collaborating in such a way that they come as one. And a very good example is, for example, your ChatGPT, for example, your LLM for use. And to me, it's just a very fine right that has a list of things to talk and you type the message and it shows everything. But if you notice, it's very fast. It's very fast, it's very reliable, you're able to switch things easily. It's able to have the picture upload, video uploads, turn down, the video down, back down, it's very, very good. I think if you actually think of it very deep, you realize that it would be as bad as contrary to what it's together. Just that once. And that sort of system there is the whole system, for example, be your brain option, your eyes, and hands, and everything. Somebody outside is just the person. Or on the inside, it's sort of little that something happens to your eye, it's by most likely affects the accuracy of the hands. and people relate to them. Your playing works on is that a good example? I don't right? Okay, you're playing for something else, right? For example, I don't think to that stance should be as good as someone playing for before. Right? And it's just because system building, everything is a system. If something happens at one point in time, it's actually going to affect several places. And the beauty of computer science is you get to realize that many of the concepts of computer science are just emulations of actual physical systems. So you could simulate your actual banking systems, for example, so like using financial systems, just like yeah, it's much just application of how we do these things physically on net and then upload to society members. Right. So bring that into ML systems. System you're going to is basically a system that already exists in terms of human interactions, in terms of human philosophy. Well, the problem is to translate it into sized formats, writing actual code for it, taking everything wrong. And that's where system becomes because I think of we as a community or as a country, we are a system. This would have a system, right? And if you're trying to do something that changes the community, you have to compensate in the form of a system, right? So it's step to system. Okay, let's look at right. Okay, that's and then so when we talk about system building for ML systems, there are a couple of questions I was going to ask. One of the very first ones is, normally data preparation is very data ingestion. Else data comes well. I think as much as it might not necessarily clear, most of the time you want to train data, just which carbon and then don't have the data start training your data on that side. But the question comes at the end of the day when you start thinking about it, when you're trying to do data from scratch. The question is, where does data come from? First things first. You need to answer a very particular question because your inability to understand where data is coming from can pretty much affect the demography of your application. Just for Nigerians, for example, and your data is coming from instead of being for Lagos, where everybody sleeps, everybody is traffic. And the data you're trying to train a model that works for Lagos is coming from Ethiopia. Now, you think that they actually have particular or fasting, for example. It's fasting, yeah, because probably all of the example is fasting, something like that. Maybe the feeling that with something like Lagos where I don't think you know anything that would get what to do is fast. I don't do scarcity. That kind maybe as a fan, I'm gonna answer it. We stop it from the promotion. What? Genius. But the thing is, where does this happen from? You can see how it is already from the Ethiopian university. You can already see how there's already some differences in possible problems. The next one is who owns data quality? Who is responsible for data quality? I just in third party service. And your data statistically backed or at the very good example is I might strip some people right now. Those will people do your firewall projects and you feel your function so but um you need you know those things now. And there are very, very common things that we do, let us pass on those people by the end of the day. It's so much budget design. It's just use budget design and also sales. I mean, you get much accuracy, right? It's pretty much straightforward. The next question you think of what happens when it's changed? And that's a very classical example. You build this system and the system works with, okay, you're working on an AI system that handles e-commerce and then you're able to handle inputs like, oh, I want to get a very light breakfast like Greek rice. Right. And let's say use your system to just okay, it out several reports and then I run an SQL query. And then user comes together to and says, I want a light breakfast. I want every possible option for rice. And let's say you have a very shallow keyword system. I don't know to see price and go to places and not accept price except one. You end up basically results that actually includes price in those cases, right? And you can see that and the thing is your system works, but it's for every input. And this is where the testing comes in. You have to go test your entire system. You have to add several kind of regression testing. Before we deploy to users, you're going to have to protect your pride as a developer and test several parts of the system. You don't test it all, like I said, your code test your eventual production. But for the most part, some people just testing your code to an extent. Right. Another question you want to ask is how to implement the project is wrong. You building a system and you actually don't plan. So you do not really prepare of having insights when the system is. You just do the same and wow, just do it like that. It's like you're pretty much saying users are going to be the ones to observe and tell what unless you're using your system every day that gets there. But the point is if you actually don't monitor your systems, users or the user of the system is one monitoring for it. And Nigerians are not applications, unfortunately. I believe for the world, now this is stuff on one first at some point. So you have to set it up to your first. Another question is what happens when the model is down? And this is, I'm just using model in this case, but you can swap model with every other thing. What happened when AWS went down? So once ago, what went down? What happened when Cloudflare went down like 2 weeks ago? There are about over 10% of the internet went down. It's not happening to anybody. There was a time when people guys sent an announcement and some agreement and things happened and then for like 40 minutes happens to be went down. Now imagine you at that point in time, your application is hosted, your event model is hosted on the present AI and it went down. You know, you come back to that. Oh, the application is down. Let's say one of the trading model. The trading model that works with stock markets where every second counts. And then people start out quick time. And then what you are telling people was I don't know, it's not my fault. To be honest, very hard. It's very technical because it's technical people. Let's get that straight. Yeah, most likely lose your job. The company loses the job for at that point in time because they find no way they're not to pay. And this is genuinely fault. So you need to answer questions like what happens when I'm building now. It's very, very essential to answer. And yeah, those are the few questions you should ask yourself when you're working with any level system thinking, right? And I said you swap models with pretty much any other thing you do. So let's think about ML as a living system. Like I said, many of the things we do today besides are just emulations of existing social parts of our lives. Now, ML as a living system, things change. ML systems are not static software. They are very dynamic. They change regularly. They age many a times. What might be valid in voice, they might not be valid today. And that's true. They also drift. They facilitate pain in the sense of, I mean, if something ages, it gradually gets to the point of being obsolete. So you can already think of it, when we're thinking of healing systems and ML, it pretty much means deploying is not just where you store. There is some active maintenance that you have to put in place when working with ML systems. Also, one very important part is being brain silent. You might not know the ML application you're using, when you're using GPT, for example, you might not see them. And they may break loudly at times. When very good example, sometimes you send a message that you don't get every time, you have to refresh your page to work. But things happen like that, they break very loudly. But there are times like they break silent, and you don't know this because at the end of the day, you still pay your insurance, right? So your ability to system to break silent, that's totally fine. The problem comes when you're not able to reduce the effect of that breakage. That's where the problem comes in. And now, I'm just going to be treated over it again, core components of your practical ML code. And almost every production ML you're working with, you had some data ingestion data, had some feature generation, yes, you're working with the imposters, device learning, so you're trying to work on. There's some learning mechanism we're going to use to, you know, train your data, your model. And there's model inference at the point where, the first step where you're not able to allow your model like to see the playground. What have you worked on? What have you learned already? What's can you do? Model inference is that point where you do things. Then decision look, you also have to consider the algorithms you put in place in determining the answers you also get. These are core practical parts of ML models. And if you're not familiar with this is just a very quick summary of that. And then the last part, which is what I just talked about not long about, not long ago, monitoring and feedback. And truth of the matter is something I wrote down here. And I'm just going to highlight so everybody can see. The moment you actually ignore one, this entire system collapses. When you reduce the energy you put in any of these five, rest assured the entire system will collapse. They are they are not dependent on each other. The accuracy of how you handle your data ingestion automatically affects your memory inference, for example. If feature generation is wrong, then a very high chance the database is affected. Position logic is wrong. I didn't have to explore that so much. The database is affected. So I didn't really like to an extent. The accuracy of your model is affected by almost every other thing. And the last part, monitoring and feedback. If you're not able to monitor your system and then see, oh, when I asked for this, I expected this, but I got this instead. That's your monitoring. And then having other people monitor it as well to give you feedback. If you're able to facilitate something like that, just believe you also reach skill like the long run. But I'm sure of the matter is those are your core components. And the entire system has to work like a well-oiled machine. You have to put every other part together in the center. Every single part of this thing has to be very accurate. Just get not projects to each of the stuff. So that it is so the resulting product should be it's so that it's useful to users because it has to be very useful. That's the point. That's how we get to sustain it. You have to be useful at the very least. And yeah, data is a good model of these things. See that thing you use that receive input and do some processing and give an output. Wow, that's my son as the real model. That's the end of the day. Real model is actually data. Data ingested, data generated, you know, data understood, data scrutinized. I think everything is practically powered by data. So your your way of handling data, the culture around data system starts above pretty much most of the practice I mentioned. So when you're working with data ingestion, feature generation, and then inference, you always have to consider what these are structures. And when I get the definition, I'm not referring to database and there's a referring to how does data coming, what does data look like, what kind of data structures in the systems. These are very important questions you have to answer. Right. Your model learns your data bugs. If there are bugs in the data, your model will learn that. Your model amplifies data bias, which is very true. And I would have given an example, but just don't do that. Well, there was a time about people saying and black people to punish. Data bias. If you have data bias, you're pretty much going to have very biased model, and that's straightforward. And your model also reflects data stillness. Why? Because your model learns from the example. Having stale data is as good as an example. And the model is going to learn because the model does not know how to question, oh, is this data actually right? It's just, that definition includes separation from the dynamic electronic. So that's straightforward. The model just takes whatever it gets and learns, and that's where you get hallucinations. Stage one. Stage two is perfect so much when you ignore hallucinations. Hallucinations stage one comes when data with confident data. Model completely data that is wrong. Such that you can also question the sense of right now. And yeah, several other things. You have your training service skill. And this one talks about uh, pretty much many times people think of when you train is when you train a data analyst, pretty much what you serve. And it just kind of just one to one mapping what I trained, what I serve. I try to think it's true. But once again, it's because of systems thinking. It's not actually true. And there are several reasons why. The pipeline you pretty much use in your development and staging. Pretty much of the pipeline you use to sell your millions to users. Right. How you handle data in when you have lesser traffic, pretty much changes from how you handle data when you have higher traffic. And the very big one is how many of us here have worked with things that any element, for example, it's text space anywhere. Or it's like you use your own to open your laptop, do something, I don't know, maybe launching or PPT or something like that. Text to realize something that what do we element of laptop? The module that is not considered can be at times. So you pretty much also carry the context of, okay, then I need to, you don't have to be fast because if me on my laptop literally look like supposed to be this for development or for running code, and it's taking me 5 seconds, 10 seconds to actually produce answers. How bad would it be for a user? It's typical user you have fish what's called attention span has decreased drastically these days. People typically don't have patience to explain their applications. The application takes a very long time. It doesn't people that most likely don't for your application process, even if it's as low as 5 seconds, 10 seconds, right? And then you need to consider all those things. So the training and service, pretty much talks about what you train your data on because it's not necessarily what you set the data. There's some graph that happens. There's a switch of things that come in place. And one of them that constitutes is your different pipeline like I talked about. There's also different pre-processing. And different pre-processing comes from something like this. Let's say, for example, I'm building an electrical system. What the electrical system was is I have data spread across the board, right? Let's say I'm about I have inverters spread across the board, and then they uh, super seven, right? Every 1 minute there's data from every inverter across the world, and I'm trying to ingest all this data, arrange all this data, probably create for example, and say contact data. You get to realize that how you handle that development was, I mean, see hard to see. Uh, 200 million devices contract to no kind. It's hard to see. It's very far. It's some constraints in the laptop, right? Because you're basically targeted. But in people like, you could actually have 200 million devices. If a particular, let's look at countries that, what you do for Africa, let's look at Africa in general, right? You could pretty much be number like 200 million devices that are also making it your server, let's say like, the other day of the matters for Africa. We done the chaos for cement, for example, right? But at that time, we took care of matters for Africa. We really scoped to me on like, and that's a piece of intelligence systems that can use to give reports to industries like China Electric now are working with large industrial Africa. And you have the people that are training and that kind of design. How you prepare the pipelines for that thing? How you process your data? To be different from how you process your data, you know, when you even training the model yourself. Because different things change. The scale alone is a long reason to start making different kind of calls. Right. There's also the concept of missing values. There are things you might have, on your end, locally. I don't look at it, I have this dependency, I have this and this installed right on time. And then things change over there in the remote world, in the world where you deploy with your model. These dependencies might change. They're working on a cloud provider that you just blindly trust that the operating system is going to be very, valid. One very common thing, if you're working with Python, for example, there are times when you might run into this issue. Making an API call the request library and then it's an SSL error, working. What my just SSL errors, right? And many a times these are like inconsistencies in constructing operating systems. And your laptop is pretty much getting most of the time. But you're working on a cloud provider that pretty much they tell you that your application is going to run on an operating system 24/7. But the truth about that is hardware dies, hardware fails many a times. Data centers express if you posted like Raspberry Pi in your house before and have like 5 Raspberry Pis and your application Nigeria, right? First is first. Even if you have an inverter, you see there are times when NEPA goes and the inverter comes from another switch can cause one of your Raspberry Pis to quickly start. There are times when you have to set with that. Plus, it's different things can happen when you have the but blindly trusted these guys and dependencies can happen. This can really change and you have to prepare for it. So that's an example of how my environmental plan was training and how I'm setting my design. And the very good of the game is real world principles. Truth of the matter is the world of your application is not as organized as your laptop. Your laptop is perfectly organized for you. You know where things are going. There's a predefined sequence of things you do on your laptop many a time. Okay, if you're trying to do for your model project on your laptop, for example, this is what goes to You know the folder when you push when you write your code, for example. That's a very good one. And these are pretty much organized locally. You can't say the same for users. A user try your code there, their phone that has switching as they will expect to. Another user will just to go with the 17 Pro Max and everything without glass screen, the rest of the mobile application, English screen, and everything's supposed to work, right? And these are things that the point is the real world is very messier than the clinical systems, and you have to pay for these systems, right? And finally, okay, not finally, but one thing to note here that while prediction is good and it's good to set users' intentions and work on it, prediction itself is not individual for the systems. Users don't necessarily want predictions. Many times, users want things that can make decisions for them. Users want things that can create actions, that can take actions. They also want things that have very desirable outcomes. It's one thing to predict, it's another thing to actually have genuine outcome. It's predicted that, and the very point is the prediction system. I predicted, okay, the user will be and they watch tutorial on my platform. And then the next thing, and how about recommend brands? I mean, if you buy the very side example, let's forget stickable. These are questions, right? And then you know don't really want to stickable. It's a very good prediction, but it's a bad outcome for the user. Right? I don't think the user can be very, very obvious what you have to do. I said, no, there's no secure about it. You know what it is? The other part is to go up with it and tell that they're having to sit down for one week or one month and tell them right? That is exactly what you know that was. And we have to build systems that we have to generate good outcome for because and it's not just it doesn't just stop at the point of um, having a model that's accurate. It's there are several parts that come into it. Maybe for example, if you work with a product designer, it's when it's called think it's called they call it style guide. It's called style guide. But it's generally part of something called branding. And branding is so very intricate. Even when your model returns results, there is a way your model should talk, for example. There's a way your model should change. So there is a tone you have to present. Yeah, these are very, very small details that you might not really pay much attention to. But when you add all these small details together, that's what actually keeps the shape. Right. Okay, yeah. An example is I'm just giving examples of places where prediction is not used out with. Very good on first score is not fraud prevention. So I'm making a fintech application. I can use my ML to go through users' transactions and give them the first score. But it doesn't mean that my system is protected from fraud prevention. It just means I'm able to assign scores to users. And then if I assign a score, I probably have marked my status. So your score is very direct, but it's from the start. So I flat my account and then have the option to push and give it over. It doesn't still cause fraud prevention. You could still be frauded, even with the very low fraud score, right? Because at the end of the day, it's just whatever time I make it, some I make it just straightforward time. Another one again is recommendation is not conversion. This is what I talked about with the next example. I recommended something, but it doesn't necessarily mean I commanded the user to that because maybe the user has not given your requirements. I haven't really convinced them enough, but I'm not giving them what they want. Another one is classification is not necessarily instead value, which is what we talked about earlier. It's very similar to recommendation, it's conversion. And this is my favorite part of this talk. Intelligence is context. It's very, very context is key. We gradually move from the era of just comparing text to actually working context with the boundary. Context is very, very key in working for them. So a model output without context is dangerous. Generally speaking, if your model is not able to text context of discussion and it just shoots out output irrespective that model, what actually works is dangerous. Not bad, but it's dangerous is the word. A very good example is computer science and technical engineering. They have a couple of things in common. They have a couple of technologies that Talking about uh, fluids, for example. Let me just word fluid. And then fluids might be really in CSS addition, for example, where the fluidity can be referring to viscosity and index. And then you read the system that is not context aware. All you just see is fluid and it starts shooting outside. In my application, that's like a temporary advice in the hundred. Is that like, what is this answer? Imagine if the user is able to, imagine the user is coming to you for intelligence responses and the user can tell that this is possible intelligence. User doesn't have to think. It's pointless to the user, for example. Right. What you need many a times is you need to have confidence in systems and discover completely accurate systems by your default first. You also need to have constraints put in place. You know that there are some lines your models should not cross. You should always, in your training process, you should always specify things like that. There are business rules to consider because at the end of the day, you're paying for your business. They have their limits. You have to comply to their limits because they pay your salary. But many a times, there are also these things called human requirements. In as much as I am very strict, or in as much as I have my rules in place to guide every account like the user, there is a human requirement sense of a human who I am ultimately trying to satisfy so they are able to override the particular settings. But don't forget, there are still constraints and business change. You have to find the balance between all four of these accuracy, constraints, business, and human requirements. For some of them, it was work hand in hand to determine the overall quality of the response. And right, a very common one and a very common formula is just intelligence equals to model, that has been trained plus group that you bring the models plus judgments. Yeah. So I'm going to start listening to very common failures it was prepared for, and I talked about some of them already. Bad inputs. Talked about missing features, the dependency thing I talked about business systems. Cold starts. Cold starts is one when your application doesn't start. If you use free services like the logo, for example, there are times the application can just go down after 5 minutes of the activity. And the user that would call the device down, people who have to restart the application for it. That takes time. Users don't have that patience. We talk about the low attention span and want everything as fast as possible. Then we have traffic spike I talked about. There's something called model timeout. Models can be so slow and then they time out because for whatever reason. A very good example, you send a message on ChatGPT and it just hangs for and after you to set time out and you have to refresh your browser, to see your output again. This never happen. Right. And there are partial outage. Talk about there's stuff, there's several outages and there's happen. And to be honest, it's not designed for it to happen. If it's designed for it, it will still happen. Or if it's designed for it, then it happens. Right. Observability for ML systems, final part. And this is just with gathering insights into your ML systems. One very good one, if you're working with AI engineering directly with sidelines, and I think it's landscape. If you're working with landscape, for example, landscape will trace or your output stream, and you already have the tracks. But it's actually doing it for the model itself. But pretty much is just monitor the inputs, monitor the outputs, monitor how it makes its decisions, and overall monitor the impact on your model on business. Because your model is costing the business more than it should, which the short is down and basically else in the match. Right. Finally, silent failure is the worst failure to an extent. Silent failure to you as a developer, you not being able to know of the video is the worst kind of failure. Silent failures to the users are pretty much the best failures. It's context that everything. And also said they don't crash, they might not alert, they might just get worse. It's about the content but act. It's much back to that particular scenario. You as a developer, and this very observability comes in place. You need to monitor your system, you can make silent failures. Feedback loops also matter. And this feedback loops come in place of if you don't have the feedback, the model will try and improve first of all. Errors will only repeat, and it is an existing bias to keep growing. That's straight up. This is straightforward. If I do not check what's going on, I don't work on it. It's a pretty much big errors over again. And one part of it that I like to talk about is a human integration. That's not a problem. It's more of a one thing to just happen is that they just we're not covering ML system. Everyone has to pay the rent because at the end of the day, you are trying to simulate the behavior of human beings in terms of digital world. The human has to verify the accuracy of the entire system. This is very important. You must catch the edge case as a human, you must provide corrections, and you're generally going to create trust. If users don't know, if users get the feeling that it's just a computer is handling everything, and it's all to make the watch mission impossible and all the other companies out, they can easily think some people are scared of computers. Yeah, it's a big one. Some of you, I would say, we start as the PC, go out on that particular what's the well, you're scared. That's a scripture. I will never believe you. Now, everyone loves to see system engineering. There are tools, there are pipelines, also CIC, gradually deploying the email systems and start container based activities. And we will also talk about it. Any other process of that, it's making sure your system is very reliable. Your modules are very reliable. Talk about ownership as well. You know what part of there is an ownership model to every there's an ownership model to every system. There is a part where me as the engineer are responsible for. There's a part where the company posts the product is responsible for. There's a part where you the user using the product are responsible for certain things. And there is always a logical ownership model when you come to system. And you need to identify this ownership model and enforce it very well. And that's what we use the system. That's my problem. At the end of the day, I'm going to jump over ownership over everything because it's quite straightforward. It talks about questions I asked before. Where is data? Where does data come from? Specials, the addresses that problem. And now, advice. You boring reliable intelligence. It doesn't have to be interesting. If you want interesting information, go and check companies. So, right? You, it can be boring, right? But resilience is nobody wants a one code unintelligent system. For people, which was also what boring was intelligent system. That's critical. That express that like probably not. And now practical wins over academic wins. To be honest, I want to be able to interpret this properly. I was able to write on it and say things like, oh, 0.5% accuracy. I don't care about the numbers that much. I care about the users giving user gets the satisfaction they want over by academic people by saying it's like, oh, I'm put the accuracy of this by XYZ percentage. Then I focus on users. And the second matter is when you pursue user satisfaction, many of these things they come as a side effect. So it's just this particular segment is just saying know how to prioritize things. Stability over novelty, right? Be very fast and very crazy and has all the extra spikes and everything. If it is not stable, it is an ultimate failure at the end of the day. And we really want to be able to maintain it because it change. Developers can if you build a system that is not maintained, it doesn't matter how intelligent it is. Data gets old, data ages, data gets data can grow bias. So I think it's a long-term failure if you're not building maintainable systems over intelligent systems. And my last part is to just say, let's move from asking questions like how good is my fail. So asking questions like how resilient is my system. So we stop focusing on just one part of the system and of how is everything related to each other. And this could apply in several forms. Right? This question just talk about so what I mentioned before. I'm going to talk about great many other things. I'm not going to talk about that. It's just quick straight points. The shifts for the great parts, the treat anyone like infrastructure, Sanos always to talk about ML ops and how you pick up systems. But my final takeaway is at the end of the day, intelligence is really engineering, what I've explained. It's not actual engineering. System change by having a system that works around very you know, even as much as brain is very smart, brain is pretty much pointless. We cannot tell the count to move. In brain is pretty much pointless if there is no count to move when the six in hand should move. So they had brain might have decided to move, there's no count there. It's that instruction was pretty much pointless. So intelligence is engineered, not trained. The model is trained when genuine intelligence comes from the knowledge and systems. Models are just components. I know you thought your dedication is to make it out the accurate, but it's just a component of the entire system. Systems create value. No matter what you do, system will create good value. If you system create good value, if one system creates bad value, value is a very generic word. Okay, actually. Right. And engineering is what makes ML real. Your ML model might be very smart and good, but engineering is what makes it very serious. And users will be able to get that and use it. Engineering makes your intelligence, your model's intelligence, user satisfactory. And my closing quotes, this is a job right. In production, intelligence is not about how smart you are. It's about how the system survives reality. Yeah, thank you. I don't think you get that question. Oh, yeah, perfect. So you have two questions. Yes, for you to have for. No, for. It's a once. All right. First question is what does ML, why does ML models create a case where the data is checked and validated? Check. Oh, you have to place the data come from. There's data you train your model on, and there's data that users from. Everything I said, everything is really data. Data is the new model. For example, when I talk about data is the new model. And I give that example of you use your system to work around, oh, I want X, Y, Z, and the user comes and says, I don't want X, Y, Z. And it's pretty much the same inputs, but your model will pretty much fail because it was not trained to handle negative terms, for example. Right? So that's a classical example of where even if your model has trained on right and very true data, if you have decision making logic, this can still fail. We can answer the question. Uh, The second question says, what mechanisms can ML engineers facilitate text when model modification? Okay, so I talked about observability ML systems, and I gave a very classic example of that, how we produce that working LLMs, right? With that, you're able to have insights into what the user wants, what's my system returns, and general system observability and get results for the action. So a very classical example is you're monitoring your model properly with that, but you're also monitoring your application generally with something like Google Analytics, right? You know that it timestamps for the session, you know when result of it, you know when result tackle the model. So much tell what result next step was. User just close the app next, or user actually click on the button to concept and line of thought. You have observability put several pieces of your system. So even know what my response, you know, what impression it made on user language. Well, that answers the second question. Then last question that you said, and what was the one question you said, says in your last book, what do you find that makes maths? It's not about how fast the model is. It's not about how reliable your model returns data. It's not about your model being able to answer questions. Like I said, your model is just a component of the entire system. And even if your model keeps accurate results, that makes it smart by default, right? It keeps the results that it wants. But giving the results is just making sure your model is smart. Those are the people intelligence system. Intelligence system is one that can handle failures, that can handle corrections, that can really understand the user, that maintains context, you know, one that you have insights into completely. That's an intelligence system. So it's the model like smart in the sense of it works, it returns the right output, giving the right inputs. But it doesn't think the entire system is too smart. And I talked about the case where, you know, you have searching that are very complex actually. So your smart system is also very fast and then so you can have 10,000 users will have the same experience as when just one user is having the same experience. That's the genuine dynamic system. That means it's intelligent. That's the last question. Yeah, the last question is just completely that you have access. Yes, you have access. Yeah, the book is for me. Right. All right. One question is, yeah, go back to the question. not for this. Next question. Last question is just talk about how does one get say a particular place to find data to the element system about their data to public. Exactly. Nobody wants to try this as a public because data is very expensive. Data is very valuable. Any data you see on carbon boxes or any other disaster like for business data in particular, you have to put your companies and sign deals with them which involve this data work. Or beyond it, and I talked about the eight down people in Ghana to Africa now. So yeah, that it's still come to hands. So it's easier for reverse savings. Companies are handling big data data companies are handling big data like this generates data models than companies who have smart engineers but don't have transaction. So for example, like I said, ownership is a part of business responsibility for its part of responsibility. It's also at times like business what we. So yeah. Thank you very much. Thank you, Cruz.